So, balik tayo sa ASTRE Handbook 1997 para doon sa mga tables, CLTD. So, ito yung CLTD Calculation Procedure 28.4, Chapter 28. So, ito yung, okay, ito yung procedure. Modify lang natin kasi dito walang partition. So, dito yung table 30. This is for flat roofs at 40 degrees north latitude. Okay. Then mga note. This is for flat roofs. So, may case naman sa mga slope, pitch roof. So, ibang case yun. So, kukunin mo na yung projected area niya. Okay. Flat roof. Yung roof number. Ang roof number, wala ka makikita dito. Andito siya. 2. Ito ang construction mo. Suspended without ceiling, with ceiling. So, ito yung roof number 2, 4, 5, 13. Tapos, gamitin mo sa table 30. Ayan, roof number 1, 2, 3, 4, 13, 10, 13, 14. 1, 2, 3, 4, 5, 8, 9, 10, 13, 14. So, ayan, numbering niya. Okay, still deck. Ito namang table 32 for sunlit wall. Sunlit wall, ito yung wall na nakaharap. Diyan ka mga nakaaraw. Kung saan nakaharap, dito, north, northeast, southeast, southwest. Ito yung may oras. 1, 2, 3, 4, 5, 12, and 24 hours from 0 to alas 3, alas 3, minus 12, plus 12, 18. Yan, alas 3 yan. Okay? Alas 12. So, ito. Then, wall number. Ito makukuha ang wall number. Dami. Ayan. Then, construction. Secondary material. Wall type mass. Yun yung mga materials mo. R value, pumasok. R value, saan ka dyan? Tapos hanapin mo dito yung wall material. C1. May mga coding yan. Ano ba yung coding? Ito na nandito. Ito yung wall number niya. Okay? Yung table niya ng mga materials. Okay? So, ito naman, table 34 sa glass production. Yan yung mga table na. Single story, sunlit wall, sound type, the cooling load factor for people, and unhooded. So, ito naman, number of hours after entry into space or equipment turn on. So, hindi ito yung time of the day. Hours and space pala. 8 hours siya duration. Nag-count ka na after entry into space or equipment turn on. So, inon mo siya na 8. So, after 1 hour, ito yan, factor mo. Pag tumagal ka na, 0 na. Kasi malamig na. Okay. At the start, 1 hour, dito ka mag-ano. So, kung 8 hours ka, ito 0.75 ang cooling load factor. Diba? Kung 8, 7 ka nag-on, so 8 a.m., 0.75. 9 a.m., 0.88. Yan, pataas ng pataas. Hanggang dito pababa. Sa ano to, iisa-isahin mo. Pero ang style dyan, mag-set ka ng ng oras. At saka yung highest mo lang kukunin dito ang factor. Pero pag tinanong ka, bakit siya highest? Hindi ba pwedeng detail? So, talaga actual. So, tingnan mo rin sila ng info yung client mo. Yan. Lighting. Ito. 38. Tapos, food equipment, about 39. Ito natin kukunin yung mga value. Okay? Cooling load example and US units or English units. An office building in Evansville, Indiana area requires air conditioning for single-story building. The following data is gathered. Location, Evansville, Indiana, US, States. Type of building, office. Number of floors, 1. Floor area is 64 by 80 or 5,120 square feet. Floor to height, 15 feet. Window, 20% of wall area. Window, double glaze. Wall number 13, U is equal to 0.2. BTUR per square foot Fahrenheit as per table 33A. Yung U, doon yun sa chapter 24. So, dito naman, table 33A, yung wall number 13, is chapter 28 as per 1997. Roof is roof number 13 then, U is 0.055 as per table 31, chapter 28 as per 1957. Windows is U is 0.55 BTU per hour per square foot Fahrenheit. Recommended ventilation is 1 air change per hour minimum or 20 CFM per person. Occupancy is 7 person per 1,000 square foot. Working is 8 hours of working, 9 to 17 hours. 9 plus 8 is 17. Sabihin yung oras dun sa standard time. Estimate the cooling load using cooling load temperature difference or the cooling load factor method. So design condition. So outdoor design condition for Evansville, Indiana area. Reference is 1997 as the handbook fundamentals, chapter 27, table 2B. So location which is 38 degrees, 38.05 degrees north latitude and 87.37 degrees west longitude. For simplicity, consider 40 degrees north latitude. So outdoor design conditions na makikita niyo sa table is 90 Fahrenheit. Outdoor design white bulb 75 Fahrenheit. Sa tandem niya. Indoor design dry bulbs is 78 Fahrenheit. Sa table to, doon lang to sa range na ano. So ito yung value natin, desired natin. Daily range is 20 Fahrenheit. So sa table din to. Relative humidity, ito yung kailangan natin, 50%. Wind velocity is 7.5 miles per hour. Miles per hour. Yung iba ginagawa, meters per hour. Pag MPH, normally, miles per hour yan. Okay. Design basis. Zone division. Due to solar exposure and sun movement, the heat gain to exterior wall and perimetric area will be much higher than the interior zone. So ito, gawa natin ng zone division. As such, the supply air requirement for exterior zone shall be much higher than the interior zone. This aspect is very important in sizing and control of air conditioning equipment, especially when single equipment AHU is feeding the entire area. For this job, the building envelope is divided into 5 zones having 20 rooms of equal area. It's assumed the two corners in each zone as one room with the same situation with other rooms on that zone. The central zone heat gain conduction through walls are 0 due to delta T 0. There is exterior wall and central zone. So this is the division. Zone 1, ito, ang size niya 64 feet, 80 feet. Ano eksakto lang na 16 by 16 ang zone. So this is zone 2, zone 3, zone 4, zone 5. Zone 1 is north, zone 2 is east, zone 4 is west, zone 5 is central, zone 3 is south. Group area, this room is 256 square feet or 16 by 16. This is room area. Okay, natin group area. Okay, yan din katapat niya. Window area for each wall is 40 square feet, which is 20% of gross wall area of 240. 16 times 15. Ang height times 0.2 is 48 square feet. The window. Net area for each wall is 192 square feet, which is the gross wall minus the window area. 240 minus 48. Each wall, itong 16 feet na yan, isang side. Dalawa na ito. So, ilan yung ang zone, ito. Zone number 1, 2, 3, 4, 5. Number of walls per room is, ilan to? Isa. Isa lang yan, side. 2, isa lang. 4, isa lang. Okay. Wall is north, east, southwest. Number 5 is interior. Number of rooms, ilan to? Yung 1, mabibilang mo dyan 4. Pero bakit 3? Ikalahati lang to di ba? So kaya 1, 2, 3. Ito naman 1, 2, 3 po. 1, 2, 3 plus hati-hati, 4. 2, ganun pala. Yan, 2 and 4. Yan, okay na? So 6, ito 6. 1, 2, 3, 4, 5, 6. Now, the area of wall is lahat siya meron. 1, 9, 2, tigi-isa. Area of window, meron. Kasi each wall may window. Bakit yung interior meron? So, area of group is 256. So, wala to. So, ayan. Tinanggal ka na. So, wala siyang window. Hindi man sa expose. So, next. Assumption. The following assumption were made during the course of calculation. So, occupancy hours for people from 9 to 17:00 hours. Be 2 persons per room. Bakit? So, doon tayong 7 over per 1,000 square foot, diba? So, divide na lang doon. Makukuha mo is 2. Ang room mo is 256 square feet. 16 by 16. Okay? The room. So, light remains on from 9 to 17. So, remains on. Sabihin, hindi siya nag-on agad. Naka-on na siya. Okay? Sabihin natin, naka-on na. Hindi siya nag-start ng on ng 9. B, 1536 watts of lights per room. Bakit 1536 yan? E, 200 watts per computer per room. F, group number is 13, as per table 31 as 1927, chapter 28, and U value for group is 0.055. G, whole number is 13, as per table 33E as 1997, chapter 28, and U value for wall is 0.2 BTU per hour per squared Fahrenheit. Yung squared natin. Window is uncoated double glazed. U value is 0.55, which is found from table 11 after 1997, chapter 29. Values of cooling load temperature difference, CLTD for roof are taken from table 30, pinakita kanina. After 1997, chapter 28. Values of cooling load temperature difference, CLTD for wall are taken from table 32, as 1997, chapter 28. K, values of cooling load temperature difference CLTD for glass are taken from table 34 as 1997, chapter 28. L, values of shading coefficient EC are taken from table 11 as 1997, chapter 29. Values of solar cooling load ECL are taken from table 36 as 1997, chapter 28. Values of cooling load factor CLF for lighting are taken from table 38 based on lights on for 8 hours. Chapter 28, Zone 5C. Values of cooling load factor CLF for people are taken from table 37 based on 8 hours in space. As 1997, chapter 28, Zone 5C. The rates of sensible heat gain, SHG, and latent heat gain, LSG, for people are taken from table T as 1997, chapter 28. Q, it is assumed that there will be one computer in this room. Also, assume that heat gain will be 680 dBm per hour. Remember na lang yung 200 watts. Source, as the Fundamental Handbook, 1997 Fundamentals. So, calculations. Look mo tayo. Calculation of CLTD correction. CLTDC is equal to CLTD plus 78 minus TR plus 70 minus 55. T sub R is the inside descent temperature 78 Fahrenheit. Tm is the main outer temperature. Outer design the arrival temperature minus tolerance over 2 is 90 minus 20 over 2 is 80. So CLTDC is equal to CLTD plus 80 minus 85 kasi yung sa 78 minus 78 na yan, di ba? So CLTD minus 5 Fahrenheit. So ito yung connection mo. So equation is U is equal to UA CLTDC or U is equal to 0.2. A is equal to 256. Wait, So equations, Q is equal to UA times CLTDC. U is equal to 0.055 and area is 256. So ito yung sa roof. Calculations is per room. The time of day at 9 AM, CLTD 16. CLTDC is 11. So dito, nakuha yan. CLTD minus 5, diba? Then Q is equal to, ito yon. U, 0.055 times area, 256 times 11 is 155. Then, ganun din. 11, 12, 13, 17. So, minus 5 lang yan. So, lalabas na to. Okay, sa roof. Sa walls, calculations of heat load due to conduction through the walls for zone 1. So, equation mo is the same. Q is equal to U, A, C, L, T, D, C. U is equal to 0.2. Area is 192. 16 times 15 times 80%. So 80% is wall area and 20% is window glazing. So times 0.8. So 192. So sa time of day, 9, 10, 11, 12, 13, 14, 15, 16, 17. CLTD mo is 9 sa table. North siya, di ba? Ang zone 1. CLTDC is minus 5 is 4. Q is 0.2 times 192 times 4. It's 154. Okay. So, yan. Ganon din dito sa lahat. Yan. So, ito yan. Zone 1. North, East, West, South. For Zone 2, ganon din. 0.2 and 192. Kunin mo yung sa East. Ito. Value. So, 16 minus 5, 11. Ganon din siya. So, 0.2 times 192 times 11 is 422. Okay? Then sa Zone 3, ganun din siya. Ito ang Zone 3 sa baba, South. So, 10 minus 5 is 5. So, 0.2 times 5 times 1 and 2 is 1 and 2. And the rest, ganun din. Zone 4, ganun din siya. Dito lang sa west niya. Okay. Zone 5 is 0 ang area mo kasi walang exposed. Zone 5 is an internal zone with no solar exposure. Therefore, heat load due to conduction to the walls for zone 5 is 0. Conduction tayo. So now for the windows, conduction pa rin. Windows heat load has two components, conduction and the radiation. So equation is UA CLTDC, U is 0.55 beta. So the area is 48 square feet from 16 times 15 times 0.2. So conduction per window per room, conduction to solar time 9, 10, 11, 12, 13, 14, 15, 16. So CLTD is 2 minus 5 is negative 3. So Q is equal to 0.55 times 48 times negative 3, so negative 79. So 10, ganun din, negative 26, and so on. Okay. So, conduction yan. So, next is the solar transmission through windows, radiation load. So, calculation of radiation load through windows for zone 1. So, yung tayong ACL sa north. Alam niyo yung isang table to, di ba? So, yan ang window mo. So, ang area is 48. So, this is 27.72 is 933. So, 27 times 0.72 times 48 is 933. Tama? So, itong iba, ganun din. Zone 2, ganun din siya. East naman ang gamitin mo. So, ito ang lalabas, mga Q value. Zone 3, ganun din. Ito ang Q, kaya lang south siya. Zone 4, west. Ito ang mga value mo. Okay. So, for the people, calculation of internal load sa people, Q sensible is N times SSG times CLF. Q latent is N times LHC. SSG sensible heat gain. LSG is sensible latent heat gain. And N is 2 people per room. So at time 9, 10, 11, 12, 17, number of people is 2. Hours after entry is 0, 1, 2, 3 people lang. Papasok siya doon. 8. So 0, SSG 250, LSG 200, CLF, tingnan mo sa table, 0.61. Ayan, pasok ka dyan. After 1 hour ito. So Q, latent, sensible and latent, then total. Lights, ang equation mo is Q lights is 3.4 times CLF times wattage. FB is equal to 1.3. So this is now 3.4 times 1536 times 1.3 times CLF 0. So okay, 0. Then the rest, ito rin. Yung value na ang Q. Then ventilation. Ventilation load has two components. One, sensible load, and two, latent load. So sensible is Q sensible 60 times CFM times rho times CP times delta T. So magiging ano siya is 1.08 times CFM delta T. Then CP is specific heat of air is 0.24. So recommended ventilation is 27 per person, 7 person per 1,000 square feet, black occupancy. For zone-wise calculation, 2 persons are assumed per room. This will ensure conservative analysis. Therefore, CFM, the airflow rate is 2 times 20 is 40 cubic feet per minute for each room. Now, Q sensible is 1.0 times CFM na delta T. Delta T is indoor minus outdoor difference. Balik. Outdoor minus indoor. So outdoor minus indoor. So T sub is 90 and T sub is 78 Fahrenheit. Therefore, Q sensible is 1.08 times 40 times 90 minus 78 or 44 times 90 minus 78. 43.2 is this is 528. So 528 BTU per hour. Latent heat is Q latent is 4840 CFM times delta W, where CFM is air flow rate 2 times 20 or 40 cubic feet per minute for each room. Delta W is the humidity ratio of indoor air minus humidity So this is outdoor minus indoor. In pound mass water per pound mass of dry air. From cytometric chart, yung indoor mo at 78 dry bulb and 50% relative humidity, W sub I is 0.0102 pound mass of water per pound mass of dry air. Outdoor is for 90 degrees Fahrenheit dry bulb and 50% relative humidity. This is na 0.0152 pound mass of water per pound mass of dry air. So delta W is W sub O minus W sub I is 0.0152 minus 0.0102 or 0.005 pound mass of water per pound mass of dry air. Therefore, Q latent is 4840 times 40 times 0.005. So Q latent is 968 BTU per hour. Alternatively, from psychometric chart, sea level HI is equal to enthalpy of outdoor air H1. The node 1 represents outer condition at 90 Fahrenheit dry bulb and 75 wet bulb. The corresponding enthalpy H sub I at this point is 38.6. 1975, 50% RH yan. H2 is equal to enthalpy at indoor conditions. The node 2 represents indoor condition at 78 dry bulb and 50% RH. The corresponding enthalpy H2 at this point is 30. Hey, 30. H sub 3 is equal to enthalpy at 3 is 32.2 BTU per pound dry air. Dito naman sa 3. Tatapat mo siya. Okay? So, the sensible is rho times FM times ST minus S2 times 60 is so magiging 0.075 times 40 times 32.8 minus 32 times 60 is 504 BTU per hour. Latent is rho CFM times S2 minus ST times 60 is 0.075 times 40 times 38.6 minus 32.8 times 60 is 1044. Okay. So, gamitin natin is yung dito. So, for appliances for each room, the number of computer in each room is 1. Therefore, Q is equal to 1 times 3.4 times or 3.4 or 200 times 200 is 680 BTU per hour. Hindi ko na binabasa yung unit na. Kitchen in central zone, Q sensible is BTU per hour is water cooler, quantity is 1 times 5970 is 5970 BTU per hour. Q sensible microwave, 2 times 160 is 2720. Q sensible coffee maker, 2 is 2 times 3580 is 7160. So coffee maker, meron siyang latent. So that is 2 times 1540 or 3080. Now the total sensible load due to kitchen is 5970 plus 2720 plus 57160 is 15,850. Total latent load due to kitchen is 3080 BTU per hour. Office services and central zone. Q sensible is small copier, 2 is 2 times 1570. Q sensible typewriter, 2 times 230 is 460. Q sensible letter quality printer, 2 is 2 times 1000 is 2000 BTU per hour. Q sensible computer is 2 times 680 is 1360 BTU per hour. Therefore, the total load due to office services is 3140 plus 460 plus 2000 plus 1360 is 6960 BTU per hour. Diyan, 2 computer. This is office services yan naman yan sa room. So the table below summarizes the heat load for each zone. So zone 1, sa mga computer to, 680. Zone 1, 3 room. So 680, 4 na room sa zone 2. 3 sa zone 3, 4 sa zone 4, zone 5. So, lahat yan may office, 660. Sa kitchen, ito, sensible, then natin. Office services, 6960. Yan, yan mo rin lahat. Ito ang total niya. So, total to. So, zone load summary. Table below summarizes the sensible latent and total load for each zone. Note that in the tables below, dito sa side, the one space load is sensible and latent load is Q row plus Q walls plus Q window plus Q people plus Q light plus Q plus C. It does not include ventilation room. This is called the total room total load. Now, total load is equal to space load plus ventilation load. This is also called gross total load. The yellow highlighted row indicates the peak load at a particular time of day. So, ito na yan. Zone 1 per room. Sa zone 1, so ito na yung mga value mo. Sa time of day, katapat niya roof, walls, windows, radiation conduction, people, latent sensible, light, ventilation, latent insensible, appliances, sensible, space load, sensible and latent, and Q total. So at time of day 17, alas 5 is anito yung peak. So yan, December 9 man. Actually, ito, roof walls, window, people, lights, plus yung appliances, na random lang yung pagkagawa nito. Ang total niya is itong space heat load. So, check nyo na lang. Medyo may discrepancy na yung pagka-total nito. Minus 79. Tama. 155 plus 154 plus 93 minus 79. Lahat ng sensible plus 0 plus except sa ventilation plus 680. So, 1843. Diba? So, ito. 155, 154 itong column na to plus ito. Minus yan kasi plus ito kasi pag minus negative. Sensible. So, ito, i-add mo to. Sensible heat niya. Tapos, lights, sensible yan. Then, wala to. Ito yan. Plus 680. Appliances, lalabas itong column na to. So, itong 400 na to, isa lang naman natin dito, di ba? Kundi itong people lang sa 400. Di pa to na. Then, i-add mo na to. 1044 plus 1843. 504 plus ayan. Total mo ito lahat, 1044 plus 504 except appliances plus 1840 plus 400 is 3791. So, ang peak niya is 17. Zone 2, ganun din siya. Ang peak niya pumasok dito sa 12787, 10, time of day 10. Okay, kung 10 a.m. Bawa. Zone 3, nasa 13 or 1 p.m. Zone 4, andyan din sa 5 p.m. Zone 5, 5 p.m. So, wala siyang walls, roof lang. Then, natin. Yan. Zone 5, kitchen room. Ito, load. So, kitchen room sa 5, meron siyang kitchen room. Ito lalabas niya. So, office services, ganun din sa 5 p.m. Room time of day 17. So, yan. Yan yung sa So, results, sensible latent peak load for each zones. So, yan na siya. Time, 9, 10, 11, 13. I-table mo. Zone 1 is 3 rooms. So, multiply mo yun ng 3. Yung sensible latent, kukuha mo doon. 5529 divided by 3. So 1843. Ito yan. Kita nyo to times 3 mo to. Dito ka kukuha sa space load. Ayan. Times 3 times 3 times 3. 3. I-table mo dito. Ayan. Pag ano naman siya kasi ito-total mo siya dito. Sensible natin. Sa buo ng area na yon. Then i-add mo yung sensible, yung total no, i-add mo. Tapos natin total mo. Okay. Yan. Lalabas, ang pinakamataas dito is total sensible is ito. Okay. So ito naman yung mga peak niya. Yan. Okay. So total sensible natin due to ventilation. Ito. Sensible and latent. 1512 times 3. Yan. So ventilation lang to. Parang may mali. So ito yung outside. Wala sa system. Sa system, additional to sa ventilation. Dagdag mo dito. Yan. So maximum sensible and latent load for buildings. Ito na. Yun. Dinagdag mo na ito. Individual. Ano naman yung data mo. Okay? Conclusion, cooling loads for individual cells are calculated. Also, the cooling load for rooms in the cells are calculated. The maximum load of the building is found at 1700 hours. The maximum space load which requires for the building are 224987 meter per hour and 11,080 meter per hour latent. Also, the maximum total loads for the building, including space and fresh air load, are 235,067 meter per hour and sensible and 28,880 meter per hour latent. Okay. So next example is the cooling load in metric units. So a school classroom is 6 meters long and 6 meters wide and 3 meters high. There is a 2.5 meter by 4 meter window in the east wall. Only the east wall window is exterior. Assume that thermal condition in adjacent spaces west, south, north, above, and below are the same as those conditions in the classroom. So determine the cooling load at 9 a.m. 12 noon on July 21. So may specific data to. Tapos ito yung iba, west, north, south, north, above, and below are the same as those of the classroom. So ibig sabihin, east lang ang consider natin wall. Other known conditions include latitude 40 degrees north, ground reflectance 0.2, clear sky with clearness number 1.0, overall window heat transmission coefficient is 7 watts per meter squared Kelvin, room dry bulb temperature is 25.5 C, permissible temperature exceeded 12.5%. Schedule of occupancy 25 people enter at 8 a.m. and stays for 8 hours. Lighting schedules 300 watts on and 8 a.m. for 8 a.m. At 8 a.m. for 8 hours. Exterior wall structure, outside surface is sub-zero. Face break 100 mm, A2. Insulation 50 mm, this is B3. Concrete block 100 mm is C3. Inside surface, this is A4, A0. Exterior window, single glazing 3 meters. No exterior shading coefficient. So AC is 1.0. Solution. So from handbook, cooling load yung exterior wall, ito yung mga coding ng layer. A sub 0, A sub 2, B sub 3, C sub P, A sub O, total. Unit resistance R value meter squared Kelvin per kilowatt is 0.059, 0.076, 1.173, and 0.125, 0.121. So total is 1.554. U is equal to 1 over R or 0.643. From ASTE 1997, Chapter 28, Table 33A, find wall type 13. So, tingin ka dun sa SI. So, from ASTE 1997, Chapter 28, Table 32, Table 8, 28 plus 32, CLTD at 9 is 9, CLTD at 12 is 14 for east wall. CLTD corrected is CLTD plus 25.5 minus TI plus T sub M minus 29.4. T sub I, inside temperature. T sub M, mean outdoor temperature, which is maximum outdoor temperature minus daily range over 2. So at 9 a.m., we have CLTD collected is 9 plus 25.5 minus 25.5 plus 31 minus 9 over 2 is 29.4 or 6.1 K. At 12 noon a.m., CLTD collected is 14 plus 25.5 minus 25.5 plus 31 minus 9 over 2 minus 29.4 is 11.1 K. So Q is equal to UALCLTD. Q is equal to 0.643 times 6 times 3 minus 4 times 2.5. Yung area ay yung area. Apat kasi yung window yata. So in this is meter squared times 6.1 is 34 watts at 9 a.m. Ito yung 6.1. Hindi ko na binabasa yung units. So also Q is equal to 0.643 times 6 times 3 minus 4 times 2.5 times 11.162 watts at noon. 6 times 3, 2.5. Ayan. 6, ang height niya is 3. Isang side lang ng wall. Tapos minus mo yung window. 2.5 times 4 ang area. Okay? So windows conduction, where from ASTRE 1997, chapter 28, table 34, CLTD at 9 is 1, CLTD 12 is 5, CLTD corrected is, ito nga, 25.5 minus T sub I plus T sub M minus 29.4. So CLTD corrected is 1 plus 0 plus 31 minus 9 over 2 minus 29.4 is equal to negative 1.9 at 9 a.m. CLTD corrected is 5 plus 0 plus 31 minus 9 over 2 minus 29.4 is 2.1 at 12 noon. Yung 0 na yan, galing yan sa 25.5 minus 25.5. Okay. So Q is equal to U is LTD. Q is equal to 7 times 4 times 2.5. Window yan. That's negative 1.9 is negative 150 watts at 9 a.m. So Q is equal to 7 times 4 times 2.5 meters squared times 2.1 is equal to 147 watts at 12 noon. Next, the solar load through glass. From ASTE 1997, Chapter 20, Table 35D, find zone type as A. From ASTE 1997, Chapter 28, Table 36, find CLF is equal to 576 at 9 a.m. and CLF is 211 at 12 noon. So Q is equal to A times SC times SCL. Q is equal to 2.5 times 4 times 1 times 576 is 5760 watts at 9 a.m. Q is equal to 2.5 times 4 times 1 times 211 is equal to 2111 watts at 12 noon. Now, the cooling load from partition ceiling indoor is 0. For people from ASTRE 1997, Chapter 20, Table 35B, find zone type B. From ASTRE 1997, Chapter 20, Table 3, find sensible latent heat gain 70 watts. From ASTRE, again, Chapter 28, Table 37, find CLF 9 at 9 a.m. 165 and CLF at 12 is 0.85. Q sensible is N times sensible heat gain times CLF is equal to 20 times 70 times 0.65 as 910 watts at 9 a.m. And 20 times 70 times 0.85 is 1190 watts at 9:12 noon. And QL is the called U latent is N times latent heat gain. Q latent is 20 times 45 is equal to 900 watts at 9 a.m. and 12 noon. Lighting. From ASTRE 1997, Chapter 28, Table 35, find zone type B. From ASTRE again, 1997, Chapter 28, Table 38, find CLF 9 as 0.75, CLF12 as 0.93. So Q lighting is W times FUL times FSA times CLF is 300 watts times 1 times 1 times 0.75 is 225 watts 9 AM. So 300 times 1 times 1 times 0.93, 275 watt at 12 noon. Appliances, all 0. Infiltration, since room air pressure is positive, we have no infiltration, so Q visible and latent is 0, or 0. Now summarize total component, gold component, wall, window conduction, window thermal transmission, partition, people, light, appliances, infiltration. So 9 AM and 12 noon, lagay mo lahat yan. So ang total is, sa 9 AM, 6796 watts, 12 noon is 3788 watts. So mas malaki yung sa 9 AM. So ito lang to. Room lang to, a room. Wala pang walang ventilation rate. Okay? So makita mo dito, mas pataas yung sa 9 AM. So this is now the end of this topic, cooling and heating load calculation.